Okay, so this is the VCAA 2019 Exam 1, question number 9. A lighting extendable string is connected at each end of the horizontal ceiling, a mass of M. So I've got mg dangling down. I'm going to break this into two vectors. It's going to be t, and that's going to be alpha there. So that's t sine of alpha, that's t cos of alpha. I can break this one into a horizontal and a vertical. That's going to be alpha. Now, because these are the same angles, these t's are going to be identically the same because it's symmetrical. However, we have a smooth ring on the string, which means that this is all one string, so therefore the tension is the same throughout the string because it just runs through a ring. So it's going to be t sine of alpha, and that's going to be t cos of alpha. So express t. Okay, so if I consider I and j, in the I component, this and this are in opposite directions, so t cos of alpha equals t cos of alpha, and of course that gives me nothing. And in the j's, I've got this is down, so mg equals those two t sine of alpha, therefore t equals mg on 2 sine of alpha, and that will be the expression for t in terms of mg and alpha. In part B, I've got a different string. It's still on a ring, and the tension of the string has a constant magnitude. So this t and this t is identically the same. So I've got to show that F equals that. Okay, so if I break my t into this angle and this angle, there's beta. So that's t cos of beta, and that's t sine of beta. Now if I break this into 2, that's 2 beta there. So that's t sine of 2 beta, and that's t cos of 2 beta. Okay, so i's and j's. In the i's, I've got this, this, and this. Therefore, f plus t cos of 2 beta equals t cos of beta. And since I'm going to be trying to find f, I get f equals t cos of beta minus t cos of 2 beta, which is t cos of beta minus cos of 2 beta. And in the j's, I've got this, this, and mg. So I've got mg equals t sine of beta plus t sine of 2 beta. So I'd like to say that t equals mg on top of sine of beta plus sine of 2 beta. Therefore, f equals, this is t, mg cos of beta minus the cos of 2 beta over sine of beta plus sine of 2 beta. And this is where I need to have a little eye on this. I like the mg, and then I've got some simplification occurring. So I know that the sine of 2 beta is 2 sine of beta cos of beta, so I'm going to do that replacement. So my bottom becomes sine of beta plus 2 sine of beta cos of beta, and I can take a sine of beta out as a common factor. I'll get 1 plus 2 sine of beta. And I like that because that gives me my sine beta on the bottom. So if I do something with the double angle formula for cos, I should be able to cancel out this. So for my cos squared of beta, so cos of 2 beta, I'm going to use 2 cos squared beta minus 1. So I keep my coses. So I'm going to have mg cos of beta minus 2 sine squared beta minus 1, which gives me mg, and then I've got minus 2 sine, I don't want sine, I want cos. 2 cos squared beta plus cos of beta plus 1, the negative on the 1. So if I crisscross that, I've got 2 cos of beta, and that will give me my 2 cos of beta squared, and 1. I want a positive, so I want the negative here. No, I want the negative there. That times that gives me negative 2 cos of beta plus cos of beta. So no, I want the negative down here. Okay, so that's going to be 2 cos of beta plus 1 and negative cos of beta plus 1. So I end up with mg negative cos of beta plus 1 and 2 cos of beta plus 1 all over the sine of beta 1 plus 2 cos of beta, and that cancels with that to leave mg 1 minus the cos of beta over the sine of beta, and that's exactly what we needed to show.